Hi, calculus students. Today we're going to keep talking about limits and algebraic ways that we can solve them. So in the last lesson, we were substituting values. If we wound up with 0 over 0 or that indeterminate form, we have to go through and factor or simplify or use a conjugate pair or some other method. Today, we're going to talk about what happens when there's a denominator in the 0. Now, I understand that a few of those problems wound up on the last practice that you weren't quite prepared for. So it was a little bit of a happy accident. And the emails and the notes that I got and Mrs. Oakes got were actually really good. Hey, I don't know what to do when I have this 0 on the bottom. We're going to address that today. So we are going to continue to learn to calculate limits algebraically. And the first example I have for that is piecewise functions. For piecewise functions, you have to look at both the left and the right. Now in pre-calculus, you used, that greater than or equal to really only define the function on one side. But for limits, you have to look at both sides. So it kind of feels like you're ignoring that left and right piece a little bit. So let's just jump into example number 1. We want to look at the limit as x approaches 1. We're going to use this left-hand notation, 1, negative. And the limit as x approaches 1 from the right. For both of these, I'm just going to use the notation f of x. I'm not going to rewrite that algebraic expression above. So the limit as x approaches 1 from the left, well, that's the lower piece right here, anytime x is less than -1. Now, I know that piece doesn't exist where x is equal to 1, but that's okay. We're at limits. I want to know as it gets close to 1. So what we'll do is we'll substitute 1 into this piece up here. So I've got -2 times 1 minus 1. This is a -2 minus 1. This is -3. And I know in pre-calculus, it kind of goes against everything you were taught. Well, that one's not underlined, so I shouldn't put it there for the 1, but that's what makes the limit a little bit different. Now the limit as x approaches 1 from the right for f of x, that's where we will use the upper function. I should probably have a different color. This one. So the right-hand side is to the right-hand side of 1. So this becomes 1 squared minus 4, which is going to be -3. Now, if both sides match, that's good news, the left and the right match, we can say that the overall limit is -3. But they don't always have to match. So if they didn't match, we'd say it does not exist, but because they do, we can say it's -3. So I haven't worked out example 2 yet, but let's check this one out. Same idea, I want you to talk about left and right hand limits. So we're going to have the limit as x approaches 2 from the left of f of x, use a different color, and the limit as x approaches 2 from the right of f of x. Remember, those don't mean -2, and they don't mean +2, they mean left and right. So 2 from the left, is that x greater than 2 or is that x less than 2? It's x less than 2, it's this one. So we're going to substitute the 2 into both of those x values. So this is 2 minus 3 in the numerator and 2 minus 2 in the denominator. So I've got a -1 over 0. Leave that as it is right now. We'll come back to that in a second. On the other one, the orange one, we are 2 from the right, so that's the right-hand side of 2. So this gives me 2 over 0. Now, are these the same or are these different? That's what we're going to have our discussion about next. So I don't want to jump right in and tell you what the answer is. I'm going to go through the next examples and maybe we'll pop back up and revisit this one. So when simplifying or factoring does not work, meaning you had that 0 over 0 and you went to simplify or factor, if that doesn't work and we wind up with a number over 0, we have a different situation. We're going to talk about infinity today. So for that first set, the answer will be, or if I have a number divided by 0, excuse me, if I have a number divided by 0, the answer will be either positive infinity, negative infinity, or does not exist. I'm going to tell you how to tell the difference. We have to look at both the left-hand side and the right-hand side. We have to break that apart. We have to look at the limit as it approaches from the left and also from the right. So we want to plug in a number, substitute a number close to C on each side to determine the sign. This will represent either positive infinity or negative infinity. And we're only going to look at the positives and negatives. If they are the same, If you get the same sign, that's your limit. So if you got positive infinity, positive infinity, positive infinity is your limit. If you have different signs, if you had a positive infinity and negative infinity, you get does not exist. So I've got 4 examples for us where we're going to go through each of those and come up with a couple of those scenarios. Maybe we get positive infinity, maybe we get negative infinity, maybe we get does not exist. All right, we're back. So let's talk about some of these examples and how we can figure out if they are positive or negative infinity. So for example 3, just like with any limit problem, the first thing that you have to do is substitute that 1 for the x. So I have 6 over 1 minus 1, which is 6 over 0. Remember, don't use those equal signs because they're not equal to real numbers. But what this does is it tells me that my choices are either positive infinity, negative infinity, or does not exist. So I have to decide which is which. So I have to take this problem and break it into a left and a right-hand limit problem. So I'm going to look at the limit as x approaches 1 from the left of 6 over x minus 1, and the limit as x approaches 1 from the right of 6 over x minus 1. Now, in our notes, we said we want to choose a number that's very, very close. You want like within a tenth. So you have to think to yourself, what's to the left of 1? Students tell me 0 is to the left of 1. That's true. You want to think even smaller. So I'm going to think 0.9. So put a 0.9 in for x and see what you get. You get 6 over 0.9 minus 1 is a negative 0.1, but the truth is I don't care about the values. I just want to know if it's positive or negative. So positive divided by a negative is negative. In fact, it's negative infinity in this case because it's not really a 0.1. Remember, it's 0. On the next one, the limit as x approaches 1 from the right, so just to the right of that would be 1.1, just a little bit bigger. So again, 6 over 1.1 minus 1 would be 6 over 0.1. It's a positive, I should have done this one like this. It's a positive over a positive, which means my result is positive infinity. Now, the two sides are different. The limit from the left is negative infinity. The limit from the right is positive infinity. Do they match? The answer is no. So we say does not exist. And if you had to justify that, it would be because the limit from the left is not equal to the limit from the right. I wanted to say one other thing. Oh, so what's really going on? This is some kind of vertical asymptote. So when we get to 1, the limit as x approaches 1 from the left goes to negative infinity. The limit as x approaches 1 from the right goes to positive infinity. It looks something like this. It's kind of your 1 over x curve. It just got shifted to the right one. And here's your vertical asymptote. Okay, so example 4, let's see what's going on. Again, the first thing you always do is substitute that 3. So this becomes 9 over 9 minus 18 plus 9. This is 9 over 0. So 9 over 0 tells me that this is positive infinity, negative infinity, or does not exist. So what we need to do is break it apart. The limit as x approaches 3 from the left of x squared over, I'm going to factor the bottom here. I think it'll be a little bit easier to see. And I know that would be the quantity x minus 3 squared. My brain just sees it better if I write it separately. And the second piece is the limit as x approaches 3 from the right. All right, so again, we have to choose values. So something that's just a little bit to the left of 3, think to yourself 2.9. If I put 2.9 in the numerator, that's a positive. If I put 2.9 in the denominator, the first one's negative and the second one's negative, but a negative times a negative is a positive. So my result is positive infinity. 3 from the right, I'm going to think 3.1 to myself. If I substitute that into the numerator, that's a positive. Into the denominator on the left, that's a positive. The other one's a positive. So I have a positive over a positive is positive infinity. So they both match. The result is positive infinity. 2 more examples. Example 5. You're tired of me saying it. But with every single one of these, you have to put 1 in. So 1 minus 3 is a -2. In the denominator, that's a 1 minus a 2 plus a 1. This is -2 over 0. Again, that tells me positive infinity, negative infinity, or does not exist. We're going to find the limit as x approaches 1 from the left, the limit as x approaches 1 from the right. Does this one factor? Yes, it does. Hold, please. All right, so if I choose a number to the left of 1, I'm thinking 1.9. The numerator is a negative. Nope, nope, not 1.9. How about just 0.9? The numerator is a negative. The denominator is a negative times a negative. So overall, the numerator is a negative. At the bottom, the denominator is a positive. This would be negative infinity, the overall sign. 1 from the right would be a 1.1. The numerator is still negative. Oh my goodness, I'm making so many mistakes here. Positive times a positive, so the overall sign here is negative infinity. Now, because the two of them match, a negative infinity and a negative infinity, the overall limit is negative infinity. For example 6, the first thing you have to do is substitute the 3. So this becomes 9 minus 6 minus 3 over 9 minus 18 plus 9. The numerator is 0. The denominator is also 0. Wait a minute, that's not a number over 0. So this is not positive infinity, negative infinity, or does not exist. That's not appropriate here. You want to go back to yesterday's rules and factor if you can. So the numerator factors into x minus 3, x plus 1 over x minus 3, x minus 3. And what do you notice that's exactly the same? X minus 3. So this becomes the limit as x approaches 3 of x plus 1 over x minus 3. Now, if I put the 3 in, I've got 4 over 0. I'm not done yet. Yesterday we got an answer, but today I have this number over 0. So I have to combine these two ideas together, and now I have to do the problem again with the limit as x approaches 3 from the left, the limit as x approaches 3 from the right. And so you want to think to yourself to the left, that's a 2.9. So 2.9 in the numerator would give me a positive, and the denominator is a negative. So overall, this one's negative infinity. In the next one, you want to think to yourself 3.1. The numerator is a positive, the denominator is a positive. So overall, we get a positive infinity. Now in this case, the left and the right don't match. So we say we have does not exist. And that's because the limit from the left does not match the limit from the right. So there you go. More about these algebraic limits. And again, those of you that were really loving algebra, this is going to be right up your alley. If you kind of had a tough time through algebra, you might struggle with these a little bit, and you want to make sure that you write out each step. Don't try to skip anything because mistakes are going to happen. So I'd like you to try practice 1.6 after this.